everyone, welcome back to my channel. Today in this video lesson we will cover a new chapter of chemistry, that is carbon and its compound. Let us see the outline of the chapter. First we will learn what is carbon, bonding in carbon, versatile nature of carbon, allotropes and organic compounds. Then we will do NCERT questions as well as some homework questions. So, what is a carbon? Carbon is an element, a non-metal and the base of life. The atomic number of carbon is 6 and its valency is 4. Earlier, organic and inorganic compounds were studied together, but later on, organic compound was made as a separate branch. Now, a question arises. Why are organic compounds studied at a separate branch of chemistry? Organic compounds are studied as a separate branch of chemistry because carbon single-handedly makes more compound than all other elements together. Organic compounds are generally the compounds with CH bonds. CH bonds, it means carbon and hydrogen bonds. Earth's crust has only 0.02% carbon in the form of minerals. Atmosphere has 0.03 carbon dioxide, and all living things are made up of carbon. Carbon, cotton, cellulose, food, our body, and wood, and many more things are made up of carbon. So now we will study bonding in carbon. Carbon has 4 electrons in its outermost shell, but it neither loses them nor gains 4 electrons. Instead, it shares the valence shell. Why can carbon lose 4 electrons? Carbon has 6 members of protons and 6 number of electrons. If carbon will lose 4 electrons from a valence shell, it would require a lot of ionization energy and it would leave 6 protons holding just 2 electrons. Why carbon cannot gain 4 electrons? If carbon could gain 4 electrons forming C4 negative anion, but it would be difficult for the nucleus with 6 protons to hold 10 electrons, that is 4 extra electrons. Since carbon atoms can achieve the inert gas electron arrangement only by sharing of electrons, carbons always form covalent bonds. Now, ionic bonds are shared by the complete sharing of the electron, and covalent bonds are made up of sharing of electrons. Such bonds which are formed by the sharing of an electron pair between two atoms are known as covalent bonds. Covalently bonded molecules are seen to have strong bonds within the molecules, but intermolecular forces are weak. Hence, they generally have low melting or boiling point. Examples of covalent bond. See, hydrogen atomic number is 1 and in its outermost shell one electron is there and it needs to complete its duplet. So when we form a hydrogen molecule, then the complete sharing of hydrogen outermost molecules take place. Same in the case of nitrogen. Outermost shell 7 electrons. To complete its octet, we need one more electron. So they share one electron and then they complete their octet. Same in CH4, methane. So one question is there. Why does carbon form compounds mainly by covalent bonding? A. There are 4 electrons in the outermost shell. B. It requires large amount of energy to form C4 anion. It shares its valence electron to its octet, or D. All of the above. The right answer is all of the above. How many electrons are there in the outermost shell of the carbon? This I told you earlier also in the starting of the video. 4 carbon. Versatile nature of carbon. The nature of covalent bonds enables carbon to form a large number of compounds. 2 properties of carbon are largely responsible for its versatile nature. First, catenation. Second, tetravalency. Catenation is the property of carbon element due to which its atom can join with one another to form long carbon chain is known as catenation. No other elements exhibit the property of catenation to the extent seen in carbon atoms. Carbon catenation is nothing but it's just a self-linking property. Okay, then silicon forms compound with hydrogen which have chain of up to 7 or 8 atoms. But these compounds are very reactive. The carbon-carbon bond is very strong and hence stable. Please take the screenshot of this slide as this is very important question. When carbon atom combined with one another, three types of chains are formed: straight chain, branch chain and closed chain. Tetravalency. Due to its large valency, a carbon atom can form covalent bonds with other carbon atoms or with even different elements. For example, oxygen, hydrogen, nitrogen, etc. The bonds that carbon form with most other elements are very strong, making these compounds exceptionally stable. Why carbon forms strong bonds? One reason is its small size. This enables the nucleus to hold on to the shared pair of electrons strongly. The bonds formed by the elements having bigger atoms are much weaker. Carbon exists in the atmosphere in the form of only carbon monoxide in traces and carbon dioxide, C. Only carbon dioxide, D. Coal. The right answer is C. Only carbon dioxide. Now, allotropes of carbon. Allotropism is a property of some elements to exist in two or more different forms in the same physical state, known as allotropes of the element. Allotropes are the various physical forms that an element can exist. Three allotropes of carbon are diamond, graphite, and Buckminster fullerene. Features of diamond: it is the hardest, does not conduct electricity, form carbon dioxide when burnt in oxygen. Each carbon atom is bonded to 4 other carbon atoms, forming a rigid 3D structure. This is the structure of the diamond, and these are the features. Now, features of graphite. It is grayish black, opaque, lighter than diamond, and slippery. Each carbon atom is bonded to a 3 carbon atom in same plane, one of its double bond. Graphite has delocalized electrons just like metals. These electrons are free to move between the layers in graphite, so graphite can conduct electricity. Please take the screenshot of this slide as this question comes in your exams, that why graphite can conduct electricity. The reason is graphite has delocalized electrons just like metals. These electrons are free to move between the layers in graphite and hence graphite can conduct electricity. Features of fullerene. Another class of a carbon electron. Dark solid at room temperature. Neither very hard nor soft like graphite. Example: Buckminster fullerene C60 is a football structure, 20 hexagons plus 12 pentagons, carbon atoms in one molecule. Now, organic compounds. Compounds of carbon are commonly called as organic compounds. They have low melting and boiling point. They are non-conductor of electricity and occurs in all flora and fauna. Oxide of carbon, carbonates, carbides, hydrogen carbonate are not considered as organic compound as they have very different properties from common organic compounds. Study of organic compounds such as hydrocarbons and their derivation is called as organic chemistry. Initially, all organic matter has derived from a natural things, or living things. So it is believed that organic compound can only be produced in living things. Vital force theory, vital force is necessary, which was proven wrong by Frederick when he prepared urea in the lab from an inorganic compound, that is ammonium cyanate, NH4CNO. Now, a question. Buckminster fullerene is an example of dash of carbon, an isomer, an isotope, an allotrope, or a functional group. The right answer is an allotrope. Now, NCERT questions. What would be the electron rock structure of carbon dioxide which has the formula CO2? This would be the structure. Please note it down. Okay, then. What would be the electron dot structure of sulfur which is made up of 8 electrons? Okay, please take the screenshot. Now, your homework question. First question, which of the following is not the property of carbon? A. Carbon compounds are good conductor of heat and electricity. B. Carbon compounds are poor conductor of heat and electricity. C. Most of the carbon compounds are covalent compounds. D. Boiling and melting points of carbon compounds are relatively lower than those of ionic compounds. Second, which of the following is the purest form of carbon? Charcoal, coal, diamond, or graphite? Thank you for watching my video. I hope you liked it. Please comment, please like, and please share my video. And don't forget to subscribe my channel. Thank you.